following video, we're going to discuss part, percent, and whole applications. So before we talk about part, percent, whole applications, the first thing we want to mention is the idea of percent. What is a percent? Really, it's a portion out of 100. Percent, think of out of 100. And so a percentage is always given to us in a ratio that expresses the part over the whole, and that number shows us what portion out of 100 does that ratio represent. So also important to know that when we are writing percent, it can be expressed as a fraction with the denominator 100, or it can be expressed as a decimal 2 places to the right. For our purposes, we're going to mostly express percents as decimals. For example, 74%. If we were to divide this number by 100 without the percent there, we would get the value 0.74. And so this is the decimal representation of that percentage. Just important to keep that in mind. So before we go into any problems, I want to talk about this triangle that you see on the side there that's not quite filled in yet, that I'm going to fill in for you over here. What it does is it allows us to make a representation or a connection between these three unknowns: part, percent, and whole. Sorry, my triangle's really not so great. I'm going to put down here whole. In the bottom right, I'm going to put percent as a decimal. And then part is going to go on the top. In these problems, we're always going to be given 2 out of these 3, and we're always looking for that third one, whether it's the whole, the part, or the percent. So when we put them into this triangle, we're going to know 2 of the 3 pieces in the triangle, and we're looking for that other piece. If we're given the 2 values on the bottom, we're going to multiply those values together. If we're given one of the values on the top and one of the values on the bottom, then we're going to divide top divided by bottom. So if we were given the part and the percent, for example, and we wanted to know what the whole was, we would take the part and we would divide by the percent as a decimal, and that would give us the whole. If we knew the whole and the percent and we wanted to know the part, then we would multiply these values together in order to get the part. If we wanted to find the percent and we knew the part and the whole, then we would simply do part divided by whole, and that would give us the answer as a percentage in decimal form. So we'll look at these examples here, and really the main thing is going to be identifying what pieces are given to us, and then of course how do we apply the triangle. Let's start with, what is 41% of 78? So we want to identify what we have here. Of course, we're given the percentage here, 41%. Before we work with it, though, let's turn that into a decimal. 41%. You can do that a number of different ways on the calculator if you just hate converting fraction decimal percent. We can remember it's percent, so we divide out of 100. We can just do 41 over 100, and then that'll tell you that it's 0.41. You also have a percentage button on your calculator. It is this value right here, this little parenthesis, but first we have to put second. We have to press second before we do that. So if we wanted to write 41%, we can do 41 second and then hit this value here, and it gives us 41% like that. And notice that when I just press equals, it gives it to me in the decimal representation also. So we can always convert percentages into decimals straight off the calculator. So we're going to write this as 0.41. And then, of course, 78 stays the same. We know that the 0.41 is our percent. And then we want to figure out, we'll ask this question one more time to figure out what 78 is. They're asking what is 41% of 78. So of 78 means it's the total. It's the whole. What we're looking for is that smaller portion. We're looking for the part. So this is the whole. And we don't know what the part is. We go and we reference our triangle here. We know whole and we know percent, and so it's just a straight multiplication. We're going to do 0.41 times 78. We get 31.98. Doesn't have to be a nice whole number. Oftentimes it is when I make exams and stuff, but this is a good example to show you that it can come out in multiple forms. It doesn't have to be a nice, neat number. X equals 3 is not always the answer, right? So 31.98 actually in this problem is going to be our part. That would be 41% of 78. Some things to consider is if you're unsure about an answer, try to put it in context that makes it more familiar to you. 41% is, it's not exactly 50%, but it's kind of close to 50%. And 50% we know is half of something. So I could have just said 78, I'm going to take half of 78, or I'm going to divide it by 2. And that gives me 39. And so just off the top, or kind of in a conceptual way, I can see, okay, 39 is 50% of 78. So 41% of 78 should be close, but definitely smaller. And surely it is here. We'll do a couple more. In the next one, it says 2.1 is what percent of 17.5? So here we're looking for the percent. We don't know what the percent is. We have a part and we have a whole. Of course, the 2.1 in this case is our part. It's just a portion of it. And then the whole, or the total amount, would be our 17.5. Going back to our triangle, if we know part and whole, then we're going to do part divided by whole in order to find out what the percentage is. So I take my 2.1, I'm going to divide by 17.5. My calculator, I'm going to go 2.1 divided by 17.5. Notice that in your calculator, the division symbol is like the fraction backslash, but it does the same operation. And here I got 0.12. Remember that when you do this calculation, that this is the decimal form of the percent. And so if you're given the decimal form and you need to go into the percentage, then you're going the opposite direction. Rather than dividing by 100 like we did in the previous one, we're going to multiply by 100 to turn a decimal into a percentage. So we know if we multiply by 100, it's going to move the decimal place 2 spaces to the right. And we can say that 0.12 is the same thing as 12%. A couple more. The next one tells us 90% of 54.4 is what? So we have our percentage here. 90% as a decimal can be written as 0.90 or 0.90. And then it asks us of 54.1 or 54.4 is what? So they're actually looking for the part because they want to know what is that 90%. This thing here is the whole. And what we don't know is the part. If it were worded in a way that says something like, actually the next example is a good example of it. 102 is 94% of what? Then they're giving us a relationship between the part and the percent. In this case, they're giving us a relationship between the percentage and the whole. So according to that, we're back on this same level thing. We're just going to multiply these values together. 0.90 times 54.4. Gives us 48.96. Most of the time I will not be asking you to round these values, but we know our rules of rounding. If I ask you to round maybe to 1 decimal place or round to the nearest whole number, we would apply our rules of rounding to make it fit. In this case, we get 48.96. Let's do this next example. The next example says 102 is 94% of what number? Now remember that this percentage here is always expressing a portion of some ratio, right? Again, 0.94 is our representation of 94%. And they told us that 102 is 94%. So 102 right here is actually a part. It's almost the entire thing, but it's not all 100%. And what we're looking for in here is the whole. So according to our triangle here, we have part, we have percent. We should be doing part divided by percent. And so I want to do 102 divided by 0.94. Don't forget to turn that percentage into a decimal. Or if you just hate that process and you want to use the percent symbol we mentioned earlier in the video, you could certainly just do that too. So 102 divided by 0.94 is a massive number. I would have told you to round to some place. Let's round to 1 decimal place, and we're going to say that this is about 108.5. Again, you could use the percent symbol. You could have done 102 divided by 94%, and that gives us that same value as well. Like I said, they don't always need to come out to be real nice numbers. Traditionally on quizzes and exams, I will make them come out pretty nice. But just remember your rounding rules in the case that I have you truncating it or rounding to 1 decimal place or something like that. Okay. Then we get some wordy ones here. We're going to do a couple of these little word ones. Oh, I shouldn't have gotten rid of my triangle, but secretly I'm glad I did because it was so poorly drawn. By the way, you will be given this triangle on your exam, so you don't need to have it, but it's good to know it anyways without having it in front of you. Now let's take a look. Oh, one more thing before we take a look at this. Percentage, remember, is this out of 100 type way of expressing the ratio of a part and a whole. Some people, instead of using percent here, may also use the word portion. A portion can be expressed as a decimal, like we saw, like 0.42 for 42%. A portion can also be a fraction. They could give us a ratio that's not necessarily out of 100, and that would also go into this spot in the box. This next example is a very good one of those. So it says an office manager determines that 2/9 of the employees he oversees have not required some required annual paperwork. Ooh, that reminds me, I have annual paperwork to do. If he oversees 120 employees, how many of them still need to complete their required paperwork? And then it says round to the nearest employee. Again, they don't always have to come out real nice. 2/9 here represents that portion or that percentage. It's not out of 100, so I'm not really going to call it a percent, but it plays the same role it plays in the percent. It's in that bottom right corner. So let's call this thing the portion. And then it says, if he oversees 120 employees, that would be the total, or that would be the whole. And then it's asking them how many still need to complete the required paperwork. That's the part that haven't gotten their job done yet, like me. And that's the one that we're looking for. So according to our triangle over here, we have our portion and we have the whole. We want to multiply these values together in order to get the part. So that's going to be 120 times the fraction 2/9. This also gives us a good opportunity to talk about fraction in this cool calculator that I had you get. All fractions can be done with this ABC button. So if I want to write 2/9 as a fraction in this calculator, I can just do 2 and then hit the ABC button up here. It gives me this weird, like, backwards L-shaped thing, and then 9. This means 2/9 right here. So what I'm going to do is I'm going to do 120 times 2/9. So I'm going to hit 2 and then ABC and 9. There's my 120 times 2/9. And it gave me this horrible number right here, which is kind of funky looking. That really means 26 and 2/3. So the U in the middle is kind of separating the whole from the leftover pieces of it. I don't really want it in that form. I'd rather it in a decimal form. So actually there's a button in here that we can use that'll change this from fraction to decimal. The PRB button up here, just above it, has a little, it's hard to see on my screen, but it has a little F to D arrow. What this does is it takes numbers that are in fractions and turns them into decimals, and vice versa. So in this one, we have it in decimal form, and we want to turn it into a fraction. Then we hit second, and then we hit our F to D button. It's going to take the answer that was a fraction and turn it into a decimal. So 26 and 2/3 is the same thing as 26.66666 forever. So unofficially, our answer can be written as 26.66666 forever and ever and ever. But we were asked to round to the nearest employee, and so we would be looking at our decimal place just to the right of the decimal, which is going to cause us to bump 26 up to 27. This was a word problem, so don't forget your unit. 27 what? 27 employees. Let's look at a couple more. So the family goes out to a restaurant for dinner and their final bill comes to $75. That sounds like a whole to me. It says if the family leaves a 10% tip when they pay their bill, how much money did they leave for the tip? So we have a $75. That was the total for their food. I'm going to call that the whole. Then I have a 10%, which of course is our portion or our percentage. We write that as 0.10. You could, if you would like, turning things into fractions more than decimals, you could have also expressed this value as 10 over 100. All percentages can be expressed as a fraction over 100. So if you really like the fraction route, frankly, most students don't, but maybe you're just the outlier. If you prefer to have it in that way, you can certainly write it either as 0.10 or as 10 over 100, and the calculation is going to be the same. In this case, we're looking for the part. How much tip do I got to leave? So I should be multiplying these values together, whole times percent. And so I'm going to do 75 times 0.10, and that's going to give me 7.5. Now 7.5, remember, we need to put proper units on these. This is money. Anytime you're dealing with a problem in money, whether it tells you or not, always give me 2 decimal places, unless it's an exact dollar, like you don't need to put $10.00. But if it has any decimal point to it, you want to make sure that it has only 2 decimal places, and of course give me a dollar sign. So don't give me 7.5, tell me the tip I'm leaving is $7.50. If this had like a really long decimal place to it, I would want you to round it to 2 decimal places. A couple more. The next one says, you and your friends are trying to decide on taking a weekend trip to Disneyland or Six Flags Magic Mountain. I guess it depends on where you are in life, right? I just came back from Disneyland before the pandemic because I have little kids. It was wonderful. That's the only place I would want to go if I have little kids. But 5 years ago, before I had kids, I was going to Magic Mountain on the regular. So, and honestly, it's a whole lot cheaper. Disneyland costs $117 per person. It's actually, I don't even know. This is dated a couple of years now. It's probably more than that. And, oh yeah, it says per weekend, but no. That's like for a day. And Magic Mountain costs $65. So here's Disney. And then we got Magic Mountain, which was $65. I'm just going to call it MM. And it says Six Flags Magic Mountain is charging what percent of a Disneyland ticket? So what percent is telling us that we need to make a portion out of this? We have a part and we have a whole. Naturally, because we're comparing it to Disney, we're referring Disney as the whole here. I'm referring to Magic Mountain as the part. And so according to our triangle, which I just got rid of, we should be dividing here, part divided by whole. And for this one, before I even do the calculation, let's round to the nearest percent. So in my calculator, I'm going to do 65 divided by 117. I get some really long value here, 0.555555556. And so if we want to round this to the nearest percent, again, it's a bunch of fives. Actually, I should put a couple fives first. And so if we wanted to round this to the nearest percent, then I would only want 2 spaces after the decimal. This 5 right here is going to go away, but before it does, I need to bump up this 5 into a 6. So I'm rounding up here to 0.56, and we know that 0.56 as a percentage should be expressed as 56%. So they're charging a little bit more than half the price for a Magic Mountain ticket as they do for a Disneyland ticket. One last problem. There are more down here for you to practice, but I just want to take a look at this one as well. And actually, we're going to do this problem now, and then we may run into this exact same problem again in the next section about markup and discount, or percent change, because there are 2 different ways of approaching the same problem, and it's important to kind of see it in both perspectives so that you make a good connection. So, back to Disney. A company sells Incredibles 2 Jack Jack toys, and currently keeps about 3,500 toys in the warehouse. In preparation for their holiday shopping, the company increases their inventory by 25%. By the end of December, 85% of Jack Jack toys have been sold. How many Jack Jack toys does this company still have? Okay, so there's a lot going on in this problem. There's percent is 25%, there's an 85%, there's numbers everywhere. It no longer looks like I can just look at the problem, identify the 2 pieces, and solve for the other one. So there's other things going on here. We're going to take it in 2 separate steps. The first step is this increase in inventory, right? The company increases their inventory by 25%. And so we started out with 3,500. Let's call that the whole. And then I want to increase something by 25%. 25% we know is a percent. We can express that as a decimal 0.25. And because it's increasing by that, what I'm going to do is I'm going to find out what is 25% of 3,500, and then I'm going to add that value to the 3,500. So the first thing I want to do is find out what is 25% of 3,500. Again, that's a part percent whole problem where we take 3,500 and we multiply by 0.25. This is going to tell me how many toys I'm going to add to my inventory. So I'm going to go 3,500 times 0.25. This gives me 875. I want to add this 875. So this is 875 additional toys. I'm going to take this 875 and I add it to 3,500. And I now have 4,375 toys. So now I'm ready for Christmas. For the holiday shopping, I should say. I'm ready for the holiday shopping. I now have 4,375 Jack Jack toys in my inventory. Now it says, by the end of December, 85% of the Jack Jack toy inventory has been sold. So now what I want to do is I'm going to take this 4,375. I'm going to find out what's 85% of this number. And that's going to tell me how many Jack Jack toys I sold. So 4,375 times 85% or times 0.85. Yeah, came out to be, I didn't write this out very well apparently. Came out to be 3718.75. Of course, you can't sell 3/4 of a Jack Jack toy, so I'm going to round this number up. And again, they don't always have to work out nicely, but usually on an exam, they'll be a little bit more well made. I'm going to call this 3719 toys sold. I sold 85% of my inventory. It means I sold 3,719 toys. The question at the end doesn't ask me how many I sold. It asks me how many Jack Jack toys does the company still have. So now we're going to take our 4375, and from that we're going to subtract 3719. Minus the number of toys we sold, 3719, tells us that we have 656 toys left. So we can use part percent whole in multiple steps in order to show us how things can grow or how things can decrease by percentages. We're going to have a new strategy to attack those kinds of problems in the next section when we start talking about absolute and relative change and we start talking about markup and discount. We'll show more ways of doing a problem like this where it doesn't come out to be a two-step process like this one is. But this shows us, though, that we can do it in small steps as long as we can identify what our part, what our whole, and what our percent or portion part is. There were a couple more problems in here that I'm going to leave to you. They're not too bad. Finding the tax rate on something. Remember that 8% is not 0.8. You see this in the back behind me? 8% does not equal 0.8. Oh, you can't really see that. That 8% is 0.08, right? Hold on, here we go. Our good friend the calculator will tell us that 8%, 0.08. Don't forget that, okay? 2 decimal places. If you're really bad at making that transition from percent to fraction and decimal, get more familiar with this one. You can send me emails if you have questions about how to use this, but remember, I ask you guys to get this specific calculator because it really easily navigates between fractions, decimals, percents. It gives you an opportunity, if you don't feel like making that change on your own, a way of inputting it straight in the calculator, okay? So practice these other ones. Let me know if you have questions, and hang out for the next video.